Hi, I'm Tom Tran, Product Marketing Manager for Power Discrete at Teradyne, and this is my 3 for 3. So today we'll be discussing how emerging markets are driving the evolution of discrete power devices and ultimately higher power requirements. Devices are getting smaller and efficiency requirements are increasing, meaning more power is getting driven through these smaller devices. This is creating challenges in both device design and testing required to ensure the end products that contain these devices meet today's demanding requirements. Which market trends are driving the need for higher power discrete devices? As we've all seen, the automotive market has skyrocketed. And this is especially true for battery electric and plug-in hybrid vehicles, with sales exceeding 2022 projections by 50% or more. And this is with the many semiconductor shortages that continue to exist even today. High power devices, that's to say devices that can handle almost 1 megawatt of instantaneous energy, being used in today's battery electric and plug-in hybrid electric vehicles are pushing power requirements higher and higher in a smaller footprint. For example, the development of silicon carbide discretes and modules used in vehicle drivetrain inverters has sped up significantly. We're seeing modules hitting the market with resistance numbers below 2 milliohms, requiring 1200 amps of current for quality measurements. And we expect these resistance values to fall into the hundreds of micro-ohm range. This amount of current now must be delivered from instrument to device repeatedly, reliably, and allow users to change out test hardware efficiently without damaging equipment. This means the connection between tester and device is a key variable in the quality of test. What makes the connection between devices and tester so important with this increase in power? So traditionally, connections for this amount of power have featured very low connection counts, often 500 insertions, before exhibiting signs of damage, or required nuts and bolts to be fastened to a DUT board or tester hardware with heavy gauge cabling. Both of these solutions meant that hardware changeovers were costly, required more intense inspection, which in turn dragged down production efficiency, and in some cases incurred additional repair costs to replace connectors. Teradyne set out to find or create a solution that would enable the connector to connect and disconnect reliably over hundreds of thousands of cycles, deliver all the required power, and be simple to change over, while providing a high level of reliability to maximize operational efficiency. This was accomplished with a new interposer that works in conjunction with Teradyne's HC2000 instrument on the ETS88 platform. This enables delivery of 2000 amps through a cable that resides over 2 meters away from the tester and connects and disconnects to the DUT board in the same manner as our classic high current resource, the HP100. This new interposer means that hardware changeover is as simple as pressing a button, swapping the DUT board, and reliably works for hundreds of thousands of cycles. With this innovation, the connector on the DUT board doesn't have to be replaced or repaired so often, improving reliability and cost of consumables. Will this replace all high current test methods in the discrete space? Absolutely not. It's not replacing AC test or thermal resistance equipment. As we move forward, the market is moving towards higher efficiency devices, which means the product mix will trend towards more devices requiring higher power testing. Previous tester resources and methods will continue to be used for products requiring less power, while newer products requiring more power will require a transition to instruments like the HC2000. It will be imperative that manufacturers plan for this transition as their product mix shifts. High power devices are pushing power requirements higher and higher in a smaller footprint. So testing these high power devices become more and more challenging, making the connection between the tester and the device a key variable in the quality and economics of test. Teradyne's solution, which encompasses our ETS88 tester, HC2000 instrument, and a new interposer, largely solves this connectivity issue while delivering high device quality and ensuring the economics of tests remain viable. Learn more at teradyne.com/ETS-88. Thanks for joining us today, and we look forward to seeing you at the next 3 for 3.